Okay, let's look at problem 6. It says when a radicand in the denominator is not a perfect square, you may need to rationalize the denominator to remove the radical. To do this, multiply the numerator and denominator by the same radical expression. Choose an expression that makes the radicand in the denominator a perfect square. It may be helpful to start by simplifying the original radical in the denominator. So for example, here, square root of 3 over the square root of 7, I have a radical in the denominator and it's not a perfect square. So I'm going to multiply the top and the bottom by square root of 7. Square root of 7 over the square root of 7 equals 1. So I'm just multiplying it by 1, and that's legal. I can multiply anything by 1 and it gives me that number back again. So let's do that here. So square root of 7 times the square root of 7. When I multiply a square root times a square root, I get that same number again. And I'll show you this. So I get square root of 3 times 7 over the square root of 7 times 7, which is 49, right? And we can take the square root of 49 and it gives us 7. So when I multiply the radical by a radical, I get that number again, over the square root of 21. So there's my answer for that one. Let's look at the second one. Okay, if I look at the second one, I see that I need to simplify first. So let's simplify that. We know that the square root of 8 is equal to 4 times 2n, and I can take the square root of that 4. So I get the square root of 7 over 2 square root 2n. So now the only thing that's in my way is the square root of 2n. So I'm going to multiply top and bottom by the square root of 2n, or by a clever form of 1. And I get, and I'm going to erase some of this so I have a little bit more space. And I'm just going to come over here to the top. So, right there. And I get the square root of 7 times 2n over 2. And remember, whenever I multiply this, I just get that same number. So I get over 2 times 2n. And when I multiply that out, I get 14n, square root of 14n over 4n. Okay? That was one way of doing it. I could have also just went ahead and multiplied by the square root of 8, if that's what you like to do. So if I multiply by the square root of 8n, I'll have to rationalize a little bit more, but I can still do it that way. I get the square root of 7 times 8n. Remember, all I do is I get 8n. All right, so now I have to just simplify. I have to simplify this, so that turns into 7 times 4 times 2n all over 8n. I can take the square root of that 4, and that gives me 2 square root 14n. I'm just multiplying the 7 times the 2n all over 8n. I still have to reduce, but I've run out of space. Come up here. And when I reduce, I get 2 goes into 8 4 times, so I get the square root of 14n over 4n. So I get the exact same answer. I might have to do a little bit more reducing, so it's your preference. All right, so let's take a look at the guided now and do one on our own. So I have the square root of 2 over the square root of 3. So I'm going to multiply by the square root of 3 on top and bottom to get rid of the radical. So I get the square root of 2 times 3, which is 6, over 3. That was easy. Let's do the square root of 5 over the square root of 18m. And I'm going to reduce it first. So I have the square root of 5. That 18, I already know it has that 9. And I can take that square root of 9. So I get square root of 5 over 3 square root 2m. Multiply top and bottom by 2m. So I get, I've run out of space again. So I'm going to get the square root of 10m over 3 times 2m, which is going to give me 10m over 6m. Okay? Let's go ahead and erase this and get the next problem. The last problem, the square root of 7s over 3. And so I get the square root of 7s over the square root of 3. So I'm going to multiply both sides, both top and bottom, by the square root of 3. And I get the square root of 21s over 3. I hope this helps.